All right, in this video we get to have some fun with antiderivatives, and we're going to do an application of them where we find a function given one of its derivatives. And so before we get started, we have to understand some basic ideas. When you think of differentiation, using the prime notation, you might think of it like this. You'll start with some function f of x, and through differentiation, you'll get f prime of x, and through differentiation, you can get f double prime of x, etc. Okay, so no problem. If you think anti-differentiation, it's the reverse. So if you start with f prime of x and you anti-differentiate, you'll get, if you start with f double prime of x and you anti-differentiate, you're going to get f prime of x. And if you start with f prime of x and you anti-differentiate, you're going to get f of x. And you could even say, if you anti-differentiate f of x, sometimes books will call that capital F of x, okay? But I want you to understand this basic idea of this flow of derivatives versus antiderivatives. It can help you keep things straight when you're working problems involving both concepts. And that's exactly what we're going to do in this video. So we'll start with the first example here. Let's say we want to determine f of x if f double prime of x equals 1 over x squared, okay? So I've got my second derivative and I want the original function. So what I'm going to do is I'm going to start by finding my first derivative, because I know that if I anti-differentiate f double prime, I will get f prime. I'll move up a level. So I will write f prime of x equals the antiderivative of f double prime of x with respect to x. And again, it takes practice to remember writing this dx, and you'll see later on why it's so important. Do not leave it off. It's very important notation. Okay? So f prime of x is the antiderivative of f double prime of x, and f double prime of x is 1 over x squared, which would be nice to call x to the negative second power for the purpose of anti-differentiation. Because now we just inverse the power rule. So the antiderivative of this tells us to increase our exponent by 1, so that's x to the negative 1, and then multiply in front by the reciprocal of that new coefficient, so it's just negative 1. The reciprocal of negative 1 is negative 1, so that's our coefficient, and we don't want to forget the ever-important constant c. So f prime of x equals negative x to the negative first plus an arbitrary constant. But this question asks us to find f of x, so now we have to proceed one more time, and we can write that f of x equals the antiderivative of f prime of x with respect to x. And f prime of x is what we just found. And because I've got this addition here, I have to put it all in parentheses as such. And then I can anti-differentiate these terms. Now, what you're going to find out is if you forget to write your c over here, it's going to propagate to be a problem in the next series of steps. So now I want to anti-differentiate, and I'm going to walk through this as a student who's first learning this might typically do. A student often will look at this, as I did as a student, as a power rule type idea. But you're going to find out that if you increase this power by 1, you get 0, and you can't divide by 0 in your coefficient. So that's a hint that something's wrong. In fact, we're going to carry down the coefficient of negative, and the antiderivative of x to the negative first, recall, is the natural log of the absolute value of x. So many things to get wrong there. Trying to use the power rule when you can't. Forgetting to put absolute values around your argument. Okay, so be really careful with that. So here's the antiderivative of negative x to the negative first. We have to anti-differentiate this constant c also. And when you anti-differentiate a constant, that constant turns into a coefficient on x to the first power. Okay, so if this were a 2, that would turn into 2x. But it's an arbitrary constant, so it just turns into cx. And what we see now is we actually get another constant because we're doing the antiderivative again, so we get another constant. And so oftentimes what we might do is maybe call the second constant C2 and go back and call the original constant C1. So I'll go back and change all of my C's initially to C1s. And so now we see that we get this new function such that if I were to differentiate this twice, I should get 1 over x squared. And you should try that out and make sure. This constant's going to go to 0 on the first derivative. This x is going to go away on the first derivative. So on the second derivative, the constant's going to turn into 0. So all that's going to be gone through the use of two derivatives. And the derivative of negative natural log is going to give you negative x to the negative 1. And when you differentiate that, you're going to get 1 over x squared. Just walking through it quickly. But this is the original function f of x if its second derivative is 1 over x squared. Now, let's see. Also, some textbooks might use c for your first constant and then maybe d for your next constant. That's also pretty common. So whatever notation you want to employ there is fine. I'm used to using the subscripts and using c multiple times. Okay, let's try another example. Let's determine f of x again. If f, we're just going to be a bit excessive here. That's okay. If f triple prime of x equals the square root of x minus 2 cosine of x. Okay? So let's get started. We need to anti-differentiate this 3 times, meaning we're likely to expect 3 different constants, c sub 1, c sub 2, c sub 3. So one step at a time. Let's find f double prime of x first by anti-differentiating f triple prime of x with respect to x. And to make my life easier, I'm going to write the square root of x as x to the 1/2 power. And because it's subtraction, I have to put this argument to the antiderivative in parentheses. So now I increase my power by 1, giving me x to the 3/2, and I multiply the coefficient by the reciprocal, which is 2/3. Now I have to be careful here because these trig functions, right? They're tricky going from derivative to antiderivative. They reverse. So I'm trying to figure out what to differentiate to give me negative 2 cosine x. And I know to get cosine, I have to differentiate sine. And to get the 2, I need a coefficient of 2. If I differentiate 2 times the sine, I get positive 2 cosine x. So I need to have a negative coefficient there. Plus a constant, which we'll call c sub 1. Okay? So that is f double prime of x given this f triple prime of x. Now let's go to the next piece, which is to calculate f prime of x through one more anti-differentiation of f double prime of x. So I get the antiderivative of 2/3 x to the 3/2 minus 2 sine x plus c sub 1. Because of the additions and subtractions, I need all of this in parentheses. And I want to anti-differentiate with respect to x. All right, forgot my 3/2 there. Sorry about that. Now we have to be somewhat comfortable with fractions. So antiderivative tells me to increase that power by 1, which is 5/2. Multiply by the reciprocal 2/5. So 2/5 times 2/3 is 4/15. Okay? Check that out for yourself. And then I have to ask, what do I differentiate to get 2 sine? Well, I know it's 2 cosine. And if I differentiate positive 2 times cosine, I get negative 2 times sine. So I need a positive here, not a negative, because the derivative of a cosine gives us that negative. The antiderivative of the constant c sub 1 is c sub 1 times x, and then plus my second constant c sub 2 through the use of this antiderivative. And so now I've got my first derivative for f. And I need to go one more step and anti-differentiate one more time to find, from f prime, to find f. So now f of x is the antiderivative of f prime of x with respect to x. So I need to anti-differentiate all of this. Let me get out of the way here so you can see. So I need the antiderivative of 4/15 x to the 5/2 plus 2 cos x plus c sub 1 x plus c sub 2. And I need all of that with respect to x. And just to clean up our workspace a little bit, let me get rid of all of this so we can focus. So now it's the same process again, just more of it. So increasing my exponent by 1 gives me x to the 7/2. Multiplying by the reciprocal is 2/7 times 4/15. So that's 8 over 105. Yeah, 8 over 105. Now I ask, what do I differentiate to get positive 2 cosine? Well, now you should be getting comfortable. That's positive 2 times the sine. Because if I differentiate a sine, I get the same. If it's a plus here, it's a plus there. Then I anti-differentiate c sub 1 x. So I keep my coefficient c sub 1, and then I use my power rule on x. So this is x to the first. So I increase that power by 1, giving me x squared, and then multiply by the reciprocal of 2, which is a half. So my new coefficient turns into c sub 1 over 2. Okay? Plus, anti-differentiating c sub 2, which is a constant, gives me c sub 2 times x. And then antiderivative of all of this introduces yet another constant, c sub 3. Now, it's very common to, you can see the constants playing out here. You've got c sub 1, c sub 2, c sub 3. It's very common to incorporate this c sub 2 into this constant. Because remember, these three constants are three arbitrary constants. They don't have to be the same, they just have to be three arbitrary constants. So this is the same thing as 8 over 105 times 7, or x to the 7/2, plus 2 sine x plus, and instead of calling this c sub 1 over 2, we could just call it c sub 1 again, because it's just a constant. Okay? And so this is your f of x function if f triple prime of x is square root of x minus 2 cosine x. So very good practice here with some of your antiderivatives, incorporating the prime notation with derivatives and antiderivatives to see how they're related. And this is a very good start to differential equations type concepts and some more advanced concepts in maybe calculus 2 down the road.